Decomposing monolithic applications into microservices for edge computing. Microservices architectures have gained significant popularity in recent years as they allow organizations to build scalable and resilient applications. With the rise of edge computing, where applications are deployed closer to the end users, it becomes essential to adapt the microservices architecture to fit the requirements of this distributed environment. In this tutorial, we will explore the process of decomposing monolithic applications into microservices specifically designed for edge computing. Understanding monolithic applications before diving into the decomposition process, it is crucial to have a clear understanding of monolithic applications. Monolithic applications are traditionally built as a single monolithic unit where all components are tightly coupled. This makes them relatively straightforward to develop and deploy, but results in challenges such as scalability, resilience, and maintainability. Microservices architecture offers several advantages for edge computing environments. Based on a decoupling of the application into smaller independent services, organizations can achieve better scalability, fault isolation, and resiliency. Microservices also enable improved development velocity through independent deployment and faster time to market. Decomposing monolithic applications into microservices requires a careful planning and step-by-step approach. Here are the key steps to follow. 1. Domain-driven design. Start by identifying the key domains within your monolithic application. Domains can be categorized based on business functionality or bounded contexts. This step helps to identify potential microservices and their boundaries. 2. Identify service boundaries. Once you have identified the domains, analyze the dependencies within the monolith. Look for areas where there is a high level of interdependencies, as they might indicate potential microservices. Define clear service boundaries and make sure you keep the coupling between microservices to a minimum. 3. Data management strategy. Decide on a data management strategy for your microservices. There are two common approaches: shared database or separate databases. Each approach has its pros and cons, so consider factors such as data consistency, scalability, and performance when making this decision. 4. Communication mechanism. Determine how microservices will communicate with each other and with external systems. Use lightweight and efficient protocols such as REST or message queues to minimize network latency and bandwidth limitations associated with edge computing. 5. Decomposition strategy. Choose an appropriate decomposition strategy based on your application's requirements. Common strategies include functional decomposition, capability-based decomposition, or event-driven decomposition. Consider factors such as scalability, fault isolation, and ease of development and deployment while selecting the strategy. 6. Implement and test microservices. Once you have defined the boundaries and decomposition strategy, implement and test each microservice independently. Ensure that each microservice is self-contained, can be deployed and scaled independently, and has well-defined contracts for communication with other microservices. 7. Deployment and orchestration. In edge computing environments, it is crucial to consider the deployment and orchestration of microservices. Use containerization technologies like Docker or Kubernetes to package and deploy microservices efficiently. Implement service discovery mechanisms to dynamically discover and communicate with microservices. 8. Monitoring and observability. Lastly, establish a robust monitoring and observability strategy for your microservices. Use tools and frameworks that provide real-time insights into the performance, availability, and errors of your microservices. This helps in identifying and resolving issues quickly in a distributed environment. In this tutorial, we have explored the process of decomposing monolithic applications into microservices specifically tailored for edge computing. Based on the steps outlined above, you can effectively design and implement microservices architecture that meets the requirements of edge computing environments. Embracing microservices in edge computing allows organizations to develop scalable, resilient, and easily maintainable applications that provide a seamless user experience.